Dear student, Assalamu alaikum. Today we are going to do our numerical and MCQs. Class 9, subject physics, chapter number 6, work and energy. Topic of today's lectures are MCQs we will do and problem 6.1, 6.2, 6.3 and 6.4 we will do. And these problems are on page number 142 and MCQs are on page number 140. If you open MCQs page number 140, I'm going to start MCQs first. This is the unit we are doing, work and energy. First of all, I will do the MCQs. I read the MCQs for you first. Can you encircle the correct answer from the given choices? The first MCQ is the work done will be zero when the angle between the force and the distance is. I read the choices. Choice 1 is 45 degree, A 45 degree, B 60 degree, C is 90 degree, and D is 180 degree. The right choice is 90 degree. C choice is the right one. If you mark down on your 9th class textbook on page number 140, the first MCQ's answer is C, which is 90 degree. If the direction of the motion of the force is perpendicular to the direction, the second MCQ I'm reading now. If the direction of the motion of the force is perpendicular to the direction of motion of the body, then work done will be A choice is maximum, B choice is minimum, C choice is zero, and D choice is none of the above. I repeat, if the direction of the motion of the force is perpendicular to the direction of the motion of the body, then work done will be maximum. A choice is maximum, B choice is minimum, C choice is zero, and the last D choice is none of the above. The right answer is C, which is zero. So you mark down C zero. The choice C is the right one. The third MCQ is now, if the velocity of the body becomes double, then its kinetic energy will be. A choices remain the same, become double, B choices become double, C choices become four times, and D choices become half. So the right answer is C, become four times. So I repeat, if the velocity of the body becomes double, then its kinetic energy will be. A choices remain the same, B is become double, C is become four times, and D is become half. The right answer is C, which is become four times. The fourth MCQ is the work done in lifting a brick of mass 2 kg through a height of 5 meter above ground will be. The first choice is 2.5 joule, B choice is 10 joule, C choice is 50 joule, and D choice is 100 joule. The right answer is 100 joule, which is D choice. So you student please mark down D choice 100 joule. So if you use the formula W is equal to mgh and just put in the values in this formula, you will get 100 joule. The formula is W is equal to mgh, m is given to me 2 kilogram and height is given to me 5, and then value of G is, it is understood 10. If you plug in all these values into formula W is equal to mgh, then you will find 100 joule. Fifth MCQ is the kinetic energy of a body of a mass 2 kilogram is 25 joule. Its speed is. I repeat, fifth one MCQ is the kinetic energy of a body of mass 2 kilogram is 25 joule. Is 25 joule. Its speed is 5 meter per second. B choice is 12.5 meter per second. C choice is 25 meter per second. D choice is 50 meter per second. The right answer is A, which is 5 meter per second. I repeat, The kinetic energy of a body of mass 2 kg is 25 joule. Its speed is A twice is 5 meter per second, B twice is 12.5 meter per second, C twice is 25 meter per second, and D twice is 50 meter per second. Your right choice is A, which is 5 meter per second. How will you solve? How it comes 5 meter per second? If you use the formula, kinetic energy formula is half mv square. If you put the values in this, you will get the velocity which will come after solve uh, 5 meter per second. The A choice is the right one. Say, six MCQs is which one of the following converts light energy into electrical energy? A choice is electric bulb. B choice is electric generator. C choice is photo cell, and D choice is electric cell. My choice C is the right one. Photo cell is the right answer. Photo cell is the right answer. You please mark down photo cell. C choice is photo cell is the right one. Now I'm moving towards seven MCQs. Seventh MCQs is when a body is lifted through a height h, the work done on it appears in the form of its A. Kinetic energy, B. Potential energy, C. Elastic potential energy, D. Geothermal energy. The right answer is B, which is potential energy is the right one. I repeat, when a body is lifted through a height h, the work done on it appears in the form of its. So you know the definition of the potential energy. Potential energy is defined as the energy possessed by a body due to its position. That's why the when we take the body at a some certain height, the potential energy will store in it. The right choice is B, which is potential energy. Next, uh, eight eight MCQs is the energy stored in coal is A choice is heat energy, B choice is kinetic energy, C choice is chemical energy, and D choice is nuclear energy. The energy stored in a coal is chemical energy. My C choice is the right one. So please student mark down C choice, which is chemical energy, is the right one for MCQs 8. Now I'm moving towards ninth MCQs. The energy stored in a dam is A choice is electrical energy, B choice is potential energy, C choice is kinetic energy, and D choice is thermal energy. So you know the energy stored in the dams. This is because the water is thrown at the some certain height. So whenever the body possesses some height, it the potential energy stored in it. The right choice is B, which is potential energy. I repeat, the energy stored in a dam is A choice is electric energy, B choice is potential energy, C choice is kinetic energy, and D choice is thermal energy. My right answer is B, which is potential energy. 10th MCQ is in Einstein mass energy equation. C is what? Okay. First choice is speed of sound. B speed of light. C speed of electron. D speed of earth. So my right choice is B. C is indicates speed of light. C stands for speed of light, which is 3 times power 8 meter per second. Speed of light. I repeat, 10th MCQs in Einstein mass energy equation. C is the speed of A choice is speed of sound, B is speed of light, C is speed of electron, and D is speed of earth. My right choice is B, which is speed of light. The last MCQs of this chapter number 6 is 11. Rate of doing work is called. A choice is energy, B choice is torque, C choice is power, and D choice is moment. So my right answer is power. As we have already discussed power definition, rate of doing work is called power. So power C is the my right choice. I repeat, rate of doing work is called A choice is energy, B choice is torque, C choice is power, and D choice is moment. So my right answer is C, which is power. So student, this is the end of the MCQs of chapter number 6. Now I am moving towards problems which we will discuss 6.12. Try to discuss 6.1 to 6.4. If you open page number 142, you will find the problems. 6.1. I'm going to start 6.1 problem. The problem 6.1 is, I read the problem statement first. A man has pulled a car through 35 meters, applying a force of 300 Newton. Find the work done by the man. A man has pulled a car through 35 meters, applying a force of 300 Newton. Find the work done by the man. So I write the given data first. Distance moved S is given to me 35 meters. Force is also given to me 300 Newton. In this numerical, I need to find out work done. And work done is denoted with letter W. Solution, you know the formula for work done is equal to W is equal to F times S. So W is equal to Fs. So if I just put the values, F is 300 and distance is given to me 35 meters. F is 300 and distance is 35 meters. If I put this one 300 multiplied by 35, I will get work done 10,500 joule. My work done W is equal to 10,500 joule is the result. Now I move towards 6.2 problem number 6.2. I read the problem statement first. A block weighing 20 Newton is lifted 6 meters vertically upward. Calculate the potential energy stored in it. This problem is 6.2 problem is on page number 142 of your 9th class textbook. Please open page number 142 of your 9th class textbook. I repeat the statement. A block weighing 20 Newton is lifted 6 meters vertically upward. Calculate the potential energy stored in it. So I will write the data first. Weight of the block is W and W is given to me 20 Newton and height is given to me H is equal to 6 meters. We need to find out potential energy and potential energy is noted with PE. Solution PE, potential energy is equal to mgh. This is the formula to calculate potential energy. To calculate the potential energy, PE is equal to mgh. You know mg is equal to W is equal to mg. I will put mg, replace mg with W. So my formula will become potential energy is equal to W times H. Just put the values. W is 20 Newton is given to me and height is also given to me, which is 6. So if I multiply this 20 multiplied by 6, I will get 120 and the unit of potential energy is joule. So in this numerical, what we are asked to find out the potential energy, and I applied the formula of potential energy, which is equal to mgh, and I replaced mg with W. So W is given to me, W is 20 Newton, W is given to me 20 Newton, and height is given to me 6 meter. So if I multiply with this 20 multiplied by 6, I will get 120 joule. My result will be potential energy PE is equal to 120 joule. I repeat this numerical 6.2. I read the statement first. A block weighing 20 Newton is lifted 6 meters vertically upward. Calculate the potential energy stored in it. Calculate the potential energy stored in it. First of all, I write the data. Given data, weight of the block is given to me. W is equal to 20 Newton. And height is A denoted with small h, which is given to me 6 meters. Potential energy in this problem, I am asked to find out 6.2 numerical potential energy. So potential energy formula is mgh. Pe is equal to mgh. I replace W with mg. Mg is equal to W. Mg is equal to W times H. Just put in the values. W is 20 Newton, which is given to me, and height is also given to me, which is 6. So if I multiply 20 multiplied by 6, it will be 120 joule. So my potential energy, which is required, which is potential energy is equal to 120 joule. Now I move towards next numerical, which is 6.3. Now I read the statement for the 6.3 numerical. A car weighing 12 kilonewton has speed of 20 meter per second. Find its kinetic energy. Find its kinetic energy. I repeat, a car weighing 12 kilonewton has speed of 20 meter per second. Find its kinetic energy. I write the given data first. Given data, weight of the car is given to me, W is equal to 12 kilonewton. And you know the unit or SI unit of weight is Newton. So I need to convert this into Newton. This is kilonewton is given to me. So kilo means 10 raised to the power 3. 12 into 10 raised to the power 3 Newton. So weight of the car is 12 into 10 raised to the power 3 Newton. In SI unit of weight is Newton. Speed is also given to me, which is v is equal to 20 meter per second. So acceleration due to gravity, this is not given, but you should know by heart. Acceleration due to gravity, value of acceleration due to gravity is g is equal to 10 meter per second square. In this numerical, we are asked to find out kinetic energy, and the formula for kinetic energy is kinetic energy is Ke denoted with Ke letter Ke. K means kinetic energy solution. So in this numerical, we are not given mass, so we will find the mass with the help of formula W is equal to mg. With W is equal to mg, we will find mass. So W is equal to mg. Just put in the value. W is 12 into 10 power 3 is given to me, and mass is not given to me, so I will find mass first. And the value of g is 10. If you 10 is multiply here, if it goes on the other side of the equation, it will be divided. So this 10 will be cancelled out with this one. So what is left? 12 into 10 power 12 kilogram. So mass unit is 12 into 10 power 2 kilogram. So I found the mass first with the help of this formula. W is equal to mg. W is given to me 12 into 10 power 3, and value of g is 10. So if you divide this 12 into 10 power 3 divided by 10, you will get 12 into 10 power 2 kilogram. Your unit of mass is kilogram. So I use the formula now to find the kinetic energy. So kinetic energy formula is half mv square. I repeat, kinetic energy is equal to half mv square. Just put in the values. The mass is given, I just found 12 into 10 power 2, and where v is given to me 20 meter per second. So I will put the values in this formula, half mv square. Kinetic energy is equal to half mv square. M is equal to 12 into 10 power 2, and v is 20 whole square. 20 whole square is 400. 20 multiplied by 20 raised to the power 2 means 20 multiplied by 20. 20 multiplied by 20 is 400. So this 2, if you cancel with this 400 with 2, so 2 to the 4 and 200 will come. So 12 multiplied by 200 is 2400 into 10 to the power 2. Now I convert this into kilo. So 240, if I write one zero will be over here, 10 power 3, 10 power 1 plus 10 power 2, you will get 10 power 3 joule. And 10 power 3 is kilo. 10 power 3 can be written as kilo. So 240 kilojoule is the right answer. Our result will be kinetic energy is equal to 240 kilojoule. I repeat this numerical 6.3. A car weighing 12 kilonewton has speed of 20 meter per second. Find its kinetic energy. So what is given to me? Weight of the car. car of weighing. Weighing means weight of the car is given to me. W is 12 kilonewton. We need to convert this into Newton because the SI unit of weight is Newton. So, kilo is 10 power 3, 12 into 10 power 3. So, I have converted weight kilo from kilonewton to Newton, which is the SI unit of weight. Speed is given to me V is equal to 20 meter per second. Acceleration due to gravity, you should know by heart, G is equal to 10 meter per second scale. So, in this numerical, we are asked to find kinetic energy. So, kinetic energy is denoted with KE. K means kinetic, E means energy. So I will, first of all, in this numerical, I'm not given mass. The mass is required in our kinetic energy formula. So with the help of this formula, W is equal to mg, I will find the mass first. So I will just put the value W is 12 into 10 power 3 Newton given to me, and mass is, I need to find out, and value of G is 10. So 10 over here is multiply, and if we go on the other side of the equation, it will be divide. So if you solve this, when the bases are same, power will be added. So this 10 power 1, when goes up, it will be minus 1. So 3 minus 1, you will get 10 power 2 kilogram. The unit of mass is kilogram. 12 into 10 power 2 kilogram. So kinetic energy is equal to half mv square is my formula. I just put the values. 1 by 2, 12 multiplied by 10 power 2. This is the weight is given to me. Sorry, mass is 12 into 10 power 2 I just found. And value of V is velocity is 20, which is this one. V is 20 meter per second. So 20 whole square is 400. If you cancel this out, you will get 200. So 200 multiplied by 12, you will get 2400 into 10 power 12. You need to convert this into kilo. So my answer is in kilojoule. So I will place one zero of to 2400. So then it will be 2240, and then 10 power 1 for this one. 2 plus 1 is 3. So kinetic energy is 240. 10 power 3 is kilo. 240 kilojoule is my result. Now I'm moving towards numerical 6.4. First of all, I read the statement of 6.4 first. A 500-gram stone is thrown up with a velocity of 15 meters per second. Find its potential energy. First thing, potential energy at its maximum height. Second is kinetic energy when it hits the ground. In this numerical, we are required to find two things. One, potential energy at maximum height, and the kinetic energy when it hits the ground. So I will write the data first. Mass of the stone is given to me, which is 500 gram, and the unit of mass is kilogram. So how will we convert this into kilogram? 500 divided by 1000, you can convert this into kilogram because the SI unit of mass is kilogram. So how will you convert? I have already told you so many times, when the unit of mass is kilograms, when SI unit of mass is kilogram, that's why I'm converting 500 gram into kilogram by dividing this by 1000. 500 divided by 1000, you can get 0.5 kilogram. So I have converted as mass into kilograms. A velocity is also given to me, which is 15 meter per second, because with this velocity, a ball has thrown vertically upward. So initial velocity Vi is equal to 15 meter per second. Gravity acceleration, the acceleration due to gravity is denoted with small g, and in this case I am taking minus 10. The reason behind taking minus 10, because the ball is thrown vertically upward, which is against the which is thrown vertically upward against the gravity. Whenever it is thrown upward, it is vertically upward, it is against the gravity. Work is to be done against the gravity. That's why. So I'm taking minus sign. Gravity acceleration due to gravity is noted with small g, which is equal to minus 10 meter per second square. So this is not given to me, but you should know by heart. and you should know when it is negative and when it is positive. When the ball is coming down, the g acceleration due to gravity will be positive. When the ball is thrown vertically upward, its velocity will be the acceleration due to gravity will be negative because work is done against the gravity. Potential energy at maximum height, this we need to find out, and you know the potential energy is noted with PE. Potential energy we need to find out, and in this numerical, we are also required to find out kinetic energy when it hits the ground. Two things are required in this numerical to find. That's why I have written to find. Now, solution. First of all, I will use the third equation of motion, and you know the third equation of motion is 2gs. With the formula for third equation of motion, 2as is equal to vf square minus vi square. But in this case, because my ball is thrown vertically upward, so GA is replaced with G and S is replaced with H. You know height is involved when uh, something is thrown vertically upward, right? So S is replaced with H. S is as therefore I have written S is replaced with H and G will be negative minus 10 meter per second square and my final velocity will be 0 meter per second. As I have read it, whenever the body is thrown vertically upwards, it is thrown with initial velocity 15 meter per second, and when it will come down, its velocity, final velocity will become zero. That's why all the initial energy converted into final energy and the final velocity will be zero. Then the body will start coming down. So 2gs is equal to vf square minus vi square. This is my third equation of motion. In the third equation of motion is 2as is equal to vf square minus vi square. Since ball is thrown vertically upward, that's why a is replaced with h and s is replaced with h and g is replaced with a is replaced with g. So my required third equation of motion will be 2gh is equal to vf square minus vi square. Now I am just putting the values. G is equal to minus 10 as I have already told you. Whenever the ball is thrown vertically upward, its acceleration due to gravity will be negative. Why? Because it is against the work is done against the gravity. So H, I need to find out the final velocity. As I have already told you, it is 0 and initial velocity is 15. So if you take 15 square, it will be 225. So this minus will be cancelled with this minus. So H I need to find out. So 20 is multiplied here. If it is go on the other side of the equation, it will be divided. 225 divided by 20, it will be 11.25 meter. And you know the potential energy formula is mgh. You should know as we have when we discussed this chapter number 6. I told you energy potential energy formula is mgh and kinetic energy formula is half mv square. So since I'm required to find out potential energy at maximum height, so formula is MPE is equal to mgh. Value of m is given to me, which I converted this in kilogram, 0.5, and g, you know the value of g is 10 and height is 11.25. I just found out height is 11.25. I just plug in the values. If you multiply this 0.5 multiply by 10 multiply by 11.25, you will get potential energy 56.25 joule. So next thing which we require is kinetic energy. In order to kinetic energy, when we are asked find the kinetic energy when it hits the ground, and you know when the body is coming down, so all the potential energy is converted into kinetic energy. So in this case, initial velocity will be 0 meter per second because at some certain height, when the ball will go at certain height, it when the all the velocity 15 meter per second is converted into final velocity. Our final velocity will be initial velocity will be 0 meter per second because we didn't give any velocity to the ball. It is coming down automatically under the action of the gravity. Initial velocity vi is equal to 0 meter per second and final velocity vf is replaced with v. So I will use the same formula. 2gh is equal to vf square minus vi square, which is the third equation of motion. So I just put the values. So in this case, Vi is equal to 0 as I have written 0 square and Vf is replaced with V. So 2, G is value is 10 because the body is coming down. So G will be positive because it is coming due to the action of gravity. So G, and I just found H. H is 11.25 as I have already told you. We found the H 11.25. We just put the value same H in this equation. So 2 multiplied by 10 multiplied by 11.25. So B square, it will come 2.25. 225. It will come 225. So V square is equal to 225. Use the formula kinetic energy is equal to half mv square. In the beginning of the chapter, in the beginning of the numericals, I told you there are two formula we will use. Potential energy is equal to mgh and kinetic energy is equal to half mv square. I will use the same formula over here. So mass is 0.5, and the velocity v square is equal to 225. So if you multiply 0.5 with 225 and divide this with 2, you will get 56.25 joule. So our kinetic energy will be 56.25 joule. You can see this in this numerical. When we found potential energy, it is 56.25 joule, and in the case of we found that kinetic energy is the same. So potential energy is kinetic converted into kinetic energy, and kinetic energy is converted into potential energy. As we have discussed the law of conservation of energy. Energy never destroyed, never created, but it converts from one form to another form. So kinetic energy, when we throw the ball up, the kinetic energy will convert it into potential energy, and the ball, when the ball is coming down, all the potential energy is coming converted into the kinetic energy. So that's why potential energy and kinetic energy have the same answer, same value, 56.25 joule. My kinetic energy is 56.25 joule, and my potential energy is same as 56.25 joule. So, student, this is the end of the today's numerical 6.1, 6.2, 6.3, and 6.4. So we discussed only four uh, numerical of chapter number 6, and MCQ we have already discussed. So this is your homework. Practice problem of chapter number 6. We discussed now the problems we discussed 6.1, 6.2, 6.3, and 6.4. Try to solve them by yourself on the rough registers. When you are adept, when you are expert in solving this, then transfer them on the need register. I will check only that one time on the need registers. This rough register is for your practice. So please practice 6.1, 6.2, 6.3, and 6.4 numerical on rough register, and try to practice as many times as you can. So, and then when you are adept, when you are expert in solving these numerical, then shift them on, transfer them on need registers only one time. I will check only one time on the need register. Please make sure when you do the numerical on the need registers, try to write the state numerical statement as well. Thank you. If you have any question regarding this